Assalamualaikum and good morning everyone. My name is Farha Adiba binti Harun and my metric number is A23A1715 and I'm from Group 4. Before we begin the analysis, I would like to briefly introduce the dataset used in this study. Data analysis is the process of collecting, organizing, analyzing and interpreting data to obtain useful information for decision making. In the insurance industry, data analysis helps companies understand customer characteristics and make better business decisions. The dataset used in this study consists of 1,338 observations and 7 main variables, namely age, gender, body mass, index, BMI, number of children, smoker status, region of residence, and annual insurance charges. Statistical analysis of this dataset provides several benefits to insurance companies. It helps them assess risks more accurately, identify factors that influence insurance charges, and understand the relationship between individual characteristics and insurance costs. In addition, it supports effective risk management, transparent premium pricing, and data-driven decision-making. In conclusion, statistical analysis is essential for ensuring that insurance operations are carried out more systematically and efficiently. Thank you for your attention. I will now pass the presentation to the next presenter for the following section.
Assalamualaikum. My name is Fadil Fazana binti Ahmad Murai. My metric number is A23A15G4. SPSS was used to randomly select a sample from the entire data for future statistical analysis. The sample size was set according to the instruction for the assignment, which involved using the smallest and the largest 2 digits number that can be derived from the metric numbers of the group members. The sample size was determined as follows: 500 minus 4 equal 496, and then 500 plus 74 equal 574 case. Hence, 496 case from the first 574 case were randomly selected from the dataset. Step 1. Viewing the original dataset. This is achieved by initializing an initial large set of the data where some of the metrics are held related, such as age, gender, BMI, children, smoker, region, and judge. Step 2. Access the select case menu. To narrow down the data, the user went to the top menu bar, then to data and choose select case. The next, open up the select case dialog box. Select a button in this box to change the default all case option to random sample of case. Step 3. Defining the sample of case. After click the sample, click button under the random sample option. A smaller sub-dialog box titled Select Case Random Sample pop up, and then select the Exactly option. Step 4. Executing and reviewing the result. After click Continue OK in SPSS, execute the command. The last screen show, rename here, Statistic Assignment Save. Sample method used in this study, SRS without replacement, is used for a particular sample of the population.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Aina Syera binti Muhammad Kamal. My metric number is A23A2040. I will explain about the 3.0 descriptive statistic. Session 3 shows the descriptive statistical analysis of the sample data. The purpose of this analysis is to summarize and describe the data clearly. There are 2 parts in this section. The first part is numerical descriptive measure, which include mean, median, mode, quartiles, standard deviation, variance, and range. This measure help us understand the average value, the position of the data. and how spread out the data is. The second part is graphical representation. Chart and graph are used to show the distribution and pattern of data visually. Overall, this analysis helps us to understand the data better before making further interpretation. Next, I will explain about the 3.1 numerical descriptive measure. The first one is the central tendency. First, we look at the measure of central tendency, which include the mean, median, and mode. This measure helps us identify the center of the data distribution. For age, the mean is 39.48 years and the median is 40 years. Since both values are very close, it shows that the age distribution is relatively balanced. For BMI, the mean is 30 and 30.79 and the median is 30.50. This indicates that most of respondents have similar BMI value and the distribution is stable. For insurance charges, the mean is 30,093 ringgit 0.32 cents while the median is 90,421 ringgit 0.97 cents. The large difference between these values suggests that some of respondents have very high insurance charges while increase the average. Next, we examine the measure of position using quotiles. For age, 35% of respondents are aged 26 years or below, while 75% are aged 53 years or below. This shows that most of respondents are between 26 and 53 years old. For BMI, the quartile value indicate that most respondents have BMI level between 26.70 and 34.48. For insurance charges, the wide gap between the quotas show that the amount paid for insurance differs considerably among respondents. Finally, we move on to the measure of variation, show how spread out the data are. The age variable has a standard deviation of 14.62, indicating moderate variation among respondent age. BMI has a lower standard deviation of 5.98, meaning that BMI values are relatively consistent. Insurance charges have the highest standard deviation, which is RM 11,855 ringgit 0.40 cent. This shows that insurance costs are very greatly, with some respondents paying much higher charges than others. So for the conclusion, age and BMI have relatively balanced and stable distribution. However, insurance charges show the greatest variation and are positively spread due to the small number of respondents with very high insurance costs. That's all from me. Thank you.
Okay, now for 3.2 graphical representations, we have 4 figures. For the first one, figure 3.2.1 shows the gender distribution of the respondents. Female respondents make up 51.2.1% of the sample, while male respondents account for 88.79%. The difference between the two groups is only 2.42%, indicating a balanced sample. This balance is important because it reduces gender bias and improves the reliability of the statistical analysis. Since both genders are almost equally represented, any conclusions drawn from the dataset are more likely to reflect the actual population. For the second, figure 3.2.2 illustrates the smoking status of respondents. The majority, which is 80.65%, are non-smokers, while only 19.35% are smokers. This indicates that smoking behavior is relatively uncommon among the respondents. However, smoking remains an important variable because it is often associated with higher health risks and increased medical costs. Therefore, smoking status may significantly influence healthcare expenditure and will be useful for further inferential statistical analysis. Next, for the third figure, 3.2.3 presents the age distributions of respondents. The average age is 39.88 years with a standard deviation of 18.62 years. The respondents range from approximately 80 to 64 years old. The relatively large standard deviation indicates that the ages are widely dispersed around the mean. This means the sample includes individuals from different age groups, making it more representative. Since healthcare is often change with age, age is expected to be an important factor influencing medical expense. For the fourth, figure 3.2.4 illustrates the distribution of medical charges. The average medical charge is 30,093.32 ringgit, while the standard deviation is 12,855.40 ringgit. The histogram shows a positively skewed distribution, meaning most respondents have low to moderate medical expense, while a small number incur very high charges. The large standard deviation also indicates substantial variation in healthcare spending. These findings suggest that factors such as age, smoking status, or health conditions may contribute to higher medical expense. Therefore, further inferential analysis is needed to identify the factors affecting medical charges.
Now I want to explain about statistic interior. Hypothesis testing is a statistical inference method used to make a decision about a population based on simple data. It involves two competing hypotheses: the null hypothesis or H0, which assumes that there is no significant difference or relationship, and the alternative hypothesis or H1, which assumes that a significant difference or relationship exists. The main objective of hypothesis testing is to determine whether the evidence obtained from a sample is strong enough to reject the null hypothesis. It also helps researchers make data-driven decisions and draw reliable conclusions without having to collect data from the entire population. Hypothesis testing is important because it improves the reliability and validity of research findings. It's widely used in business, finance, economics, and social science research to support objective decision making based on statistical evidence. In this study, we select smoker as the grouping variable and charger as the dependent variable for the independent sample t-test. This is because smokers consist of two categories, namely smokers and non-smokers, making it suitable for comparing the means insurance charges between the two groups. For ANOVA, we select region as the grouping variable and charge as the dependent variable. Since region consists of four categories, ANOVA is the most appropriate method to compare the main insurance charge across different regions. The hypothesis testing process consists of five essential steps. First, starting the null and alternative hypothesis. Second, determine the signification level, usually 0.05. Third, selecting the appropriate statistical test. Fourth, calculate the test statistic and p-value using SPSS. And finally, making a decision to either reject or fail to reject the null hypothesis based on the result obtained. In conclusion, hypothesis testing provides a systematic and scientific approach for analyzing data and making meaningful statistical conclusions. Thank you.
Next, I will present section 4.2, which is using t-test. A t-test is a statistical method used to determine whether there is a significant difference between the means of two groups. In this study, an independent sample t-test was conducted to compare the mean age between two independent groups. The hypotheses for this test are: the null hypothesis HO states that there is no significant difference in the mean age between the two groups. The alternative hypothesis H1 states that there is a significant difference in the mean age between the two groups. Before interpreting the t-test result, Leven's test for equality of variances was examined. The significance value obtained was 0.415. Since this value is greater than 0.05, the assumption of equal variances was met. Therefore, we use the result from the equal variances assumed rule. The independent sample t-test produced a t-value of 1.038 with 15 degrees of freedom. The p-value obtained was 0.317. Since the p-value is greater than the significant level of 0.05, we fail to reject the null hypothesis. This means that there is no statistically significant difference in the mean age between the two groups. Although there was a mean difference of 0.73 years, the difference was not large enough to be considered statistically significant. In addition, the 95% confidence interval ranged from negative 0.18 to 20.64. Since the interval includes 0, it further supports the conclusion that there is no significant difference between the group. In conclusion, the independent sample t-test show that age does not differ significantly between the two groups in the sample data set. Therefore, the null hypothesis was not rejected.
This slide presents the ANOVA analysis result, which is we use to determine whether there is a significant difference in the mean age of respondent based on the number of children they have, specifically 0, 1, or 2 children. First, let's look at the descriptive table at the top. This study includes a total sample size, which is N, of 428 respondents. We can see at the mean column, respondents with 0 children have a mean age of 38.33 years old. Those with 1 child average 40.21 years old, and those with 2 children average 40.25 years old. Descriptively, there is a slight visual difference, but to find out if this difference is statistically meaningful, we look at the next table. Moving down to the ANOVA table, there is where we compare the variance between the group against the variance within the groups. The two key metrics to focus on here are the F statistic, which is 0.853, and most importantly, the significant value or p-value, which is 0.427. In statistics, a significant value greater than 0.05 means the result is not statistically significant. Because our significant value is 0.427, which is well above 0.05, we conclude that there is no significant difference in mean age across the different group of children. In simple term, age does not statistically differ whether a person has 0, 1, or 2 children in this data set. That concludes my presentation on this slide. Moving on to this slide, since our overall ANOVA was not significant, we look at the post hoc multiple comparison and homogeneous subset table to confirm the relationship between specific pairs. First, Let's look at the multiple cooperation table on the left. This metric evaluates the mean difference in age between every pair of group using method like two-key HHD. If we look closely at significant column for the two-key HHD method, we can see that comparing 0 children versus 1 child gives a p-value of 0.518, and comparing 0 children versus 2 children give a p-value of 0.572, and comparing 1 child and 2 children give a p-value of 1. As you can see, every single pairwise comparison yields a p-value much greater than 0.05. This confirms that no individual pair of group has a statistically significant difference in mean age. To visualize this even better, let's look at the homogeneous subset table on the right. Notice how all three groups, which is 0, 1 and 2 children, are clustered together inside a single column, which is on subset 1, because they all fall into the exact same subset. It visually confirms that the mean age across these categories are statistically equivalent and homogeneous. To wrap up our analysis, our final statistical decision is based on our original p-value, which is 0.427, which is greater than the standard 0.05 threshold. Therefore, we fail to reject the null hypothesis. In final conclusion, there is no statistically significant difference in the mean age of the insured based on the number of children they have. Any minor fluctuation we see in the mean are merely due to random sampling variation and hold no real significance in the broader population.
Decision and conclusion. To make a statistically decision, the significant value obtained from the ANOVA table is compared against the standard significant level, A, equal to 0.05. The analysis indicates value of P equal to 0.427 more than 0.05 because the significant value is greater than the A label. The statistically decision is to fail to reject the null hypothesis. Final conclusion, it can be concluded that there is no statistically significant difference in the mean age of the insured based on the number of children they have. F equal to 0.853, P equal to 0.427. The minor fluctuations in mean age across the three groups are merely due to random sampling variation and hold no real significance in the broader dataset population. As a result, further parsing of the post-hoc table is statistically unnecessary.
My name is Nur Atira binti Adenan. My nomometric is A23A1718. For conclusion, my opinion is this study applies statistical techniques using SPSS to analyze factor influence insurance charge. For descriptive analysis show balanced distribution for age and BMI, while insurance charges are highly skewed due to extreme values. Differential result test and ANOVA indicate no statistically significant differences, suggesting weak relationship among tested variables. Finding highlight that valuations are mainly influenced by random sampling, but factors like smoking and high cost case remain important considerations. Overall, this study proved that statistical analysis is essential for data-driven decision-making, improving risk assessment, and enhance pricing strategy in the insurance industry. Thank you.